The next thing to do is to control the particle color. If I look under the modifiers, under the particle tasks, I'll find the modify particle color as well as the modify particle size compounds, which we'll both be using in a moment. I'll actually just plug in the modify particle color after the forces, so I'll make room by adding a port after port 3 and pull in the modify particle color. Plug that into the port 4 input and make room again and double click to open. Since I've already set the particle age limit, I can use the particle age percentage as a source parameter, which is going to specify a value between 0 and 1, or 0 and 100. And what I'm actually going to do is I'm just going to set a new color using this gradient for a ramp along the age percentage. So the blue to green represents values from 0 to 100% of the particle's life. So as we play, we'll see the particles move through a color shift towards green. So at the midpoint of their life, you can see that they're starting to turn green. So all I really want to do here is map in colors that are a little bit lighter at the beginning, and I'm going to really have them darken and thicken up as the smoke accumulates. So the smoke's moving quite a bit faster in the initial part of its life, and then slowing down as it just accumulates and densifies up in the upper levels. I'll bring the colors down. Maybe I'll even add in a bit of a mid-tone here, just giving the particles a slight tint, maybe a little touch of blue in there. And maybe even this color is a bit too light. So I'll bring that color down a little bit as well. Okay, so we're getting our color shift, and on top of that I want to use the particle size, and I want to increase the particle size based on the same age percentage. So if I pull in the modify particle size compound, again making way for a port on the ice tree root, I'll bring in the particle size and execute that into port 4. So again, when I look at my parameters, my source parameter can be based on age percentage, the current time, or an external value. And I'm going to, again, just going to use an age percentage. And rather than mapping a gradient over age percentage, we're mapping a function curve profile over age percentage. So at the early phase of the particle's life, it's almost invisible, or small, I should say, and that size begins to increase with age. And we control the ramp in terms of size, the min-max size that's being mapped along age by our particle multiplier. So I can really thicken up those particles as they move higher up. I've got a fairly Gaussian curve describing the ramp up from small to large particle. So I don't want the smallest particle to have a size of 0. I want it to actually start with some size. So actually start the particles at a value of about 0.2, which is again taking into account their initial size. And here we're starting to get something that looks a little better. What I'm going to do is increase the size a little faster through the early portion of its life. So if you actually look as I'm moving the function curve, I'm able to control the transition from a small size particle to a larger size, so they occur a lot quicker. If I wanted to kind of prolong it, you could do something like that, where they grow substantially at about 50% of their life. So I'm just going to, again, strike a bit of a balance here. That looks pretty good. I'll just do that a little quicker. There we go. Say something like that. Okay, so that takes care of our next problem. We now have got smoke emitting from the burnt out wreckage of the building, and we're getting a color shift and a size shift along the age percentage.